Hey, mathletes. What we're going to take a look at in this video is vertical asymptotes. Now, you're probably pretty familiar with vertical asymptotes. We did a lot of work with them back in 30-1, didn't we? So what we'll do now is we'll look at them again, but from a calculus perspective. So again, let's always start with the visual. So here we are looking at the function f at x is equal to 1 over x squared. And the graph is to the right. This is determine the limit as x approaches 0. Well, as x approaches 0, well, let's again look at limits from the left-hand side and the right-hand side. So as we approach from the left, what we're going to see is our y values are going to grow without bound. And as we approach from the right, we're going to see that our y values also grow without bound as they approach x is equal to 0. So that's how we know that we're approaching a vertical asymptote, because as we get closer and closer and closer to these values, we're going to positive infinity. So that's how we'll figure this out when we're doing this algebraically. So since both these values go off without bound, we know that this is going to positive infinity. Now, I want you to know that the real answer here again does not exist, but we'll put positive infinity so we have a sense of direction, or negative infinity for that matter. So the function f at x will have a vertical asymptote at the line x is equal to a if we have the following limits. As x approaches a from the left, it goes to positive or negative infinity. As x approaches a from the right, it goes to positive or negative infinity. Or if you want to say the entire limit goes to positive infinity, because they go the same way on both sides. Okay, so what we're going to do is first to find our vertical asymptotes, we'll determine which values of x make the denominator equal to 0, because that's the one number in life we can't divide by or the world explodes, right? And then we'll find the one-sided limits at these moments. All right, let's just try two of these. You're used to these, so it's not that complicated. So the first thing I want to recognize is x can't equal 6. So what I'm going to do, or what we're going to do then, is we're going to find the limit as x approaches 6 from the left of f at x. And we'll find the limit as x approaches 6 from the right of f at x. Okay, so what happens here? So I'm going to sub in a number like so close to 6 from the left that essentially it is 6. So I'm going to think to myself, I'm going to sub in something like, where am I going to write? I'll write it down here so it's not in the way. From the left. From the left, I'm going to sub in a number like, oh, I don't know, 5.999999999, like that. Okay, so what would happen if I sub that in? Well, what I would get is 2 minus 5 over a really small negative, really small negative number squared. Well, what would happen there then? Well, a really small negative number squared would make it a really small positive number. So now what I've got is 2 minus 5 over a really small positive number. Well, what does that give me? Well, 5 divided by negative 5, I should say, divided by a really small number is going to give me then negative infinity. Okay, let's try that again. Let's try it now from the right. So from the right, I'm going to sub in a really small number, or a number close to 6, that. So what do I get this time? So this time I get 2 minus 5 over, well, 6.0001 minus 6 is a small positive. And in fact, it's a small positive squared. So negative 5 divided by a small positive number squared is negative infinity. And 2 minus infinity is still negative infinity. So what did we just find? We just figured out that at positive 6, there's our vertical asymptote. What this graph is doing is it's going to, I don't quite know where the, oh, I do know the horizontal asymptotes at 2, is this is going to approach like this. Okay, so there, not only now can we find out where the vertical asymptotes are from 30-1, now you can actually tell me what direction they're approaching, or they're tending to. Okay, let's try one more. Let me just erase my work, which is making my screen jump all over the place, which is driving me nuts. I don't know why it's doing that. Okay, let's try one more, friends. Let's stick in hot pink. We don't have enough hot pink in our life. Okay, so the first thing I would do is factor it. And it sounds like that. So now I can tell that my non-permissible values are x is equal to -2 and 3. So those are our vertical asymptotes. So let's go check these limits. So we're going to check the limit as x approaches -2 from the left. And we're going to check the limit as x approaches -2 from the right. We have to check both sides. So when I sub a number close to -2 into our denominator from the left, like -2.0001, what I'm going to get is I'm going to get a negative in the top over -2 minus 3 is a negative there, and -2.0001 times a negative or plus 2 is still a negative. And so what I'm going to have at the end of all of this is going to end up going to -infinity as I go from the right. So I'm going to sub in a number like -1.999. So again, I'm going to get a negative in the top, a negative here, but this time I'm going to get -1.999999 plus 2 is a positive. So in this case, I'm going to go to positive infinity. So on this graph, friends, the function on either side of our vertical asymptote actually switches. So this is again how we're going to tell these things what they look like without a graphing calculator. We check the limits on both sides. Okay. Okay, there's that one. So let's go. We've got to also check when x is 3. So what I'm going to do here is I'm just unfortunately just going to spend a little bit of the time. We're racing right here because silly teacher didn't put another page on his PDF to have enough work, right? So I'm just going to erase a little bit there. Sorry about that, friends. Can't be perfect all the time, right? That's my motto. Can't be perfect all the time. Okay, so let's try this. So now when x is 3. So I'm going to go when x is 3 from the left. Switch to blue here when x is 3 from the left, and when x is 3 from the right. So from the left, I'm going to sub in something like 2.999999. So I'm going to get positive in there. 2.9999 minus 3 is a negative and a positive. So this is going to go to -infinity. And from the right, I'm going to sub in 3.0001. So I'll get a positive and a positive and a positive, and I get positive infinity. Okay, let's take a shot at what this thing looks like. Okay, let's get rid of all this. What does this one look like? Again, it's not perfect. That'll be what we do in our final lesson in this unit. So what do I know? We've got a vertical asymptote at -2. We've got a vertical asymptote at +3. There's 3, there's -2. Okay, so what this thing does is, as we approach -2 from the left, we go to -infinity. So as we approach -2 from the left, we go to -infinity. As we approach -2 from the right, we go to positive infinity. Then it's going to come down here. And as we approach 3 from the left, we're going to go to -infinity. And as we approach 3 from the right, we're going to go to positive infinity. And so that function is going to look something just like that. So again, friends, what's really important when you're finding vertical asymptotes. It's not just enough to tell me where the vertical asymptote is anymore. I need that direction. And so that's why I need you checking these one-sided limits right here to see what's happening. Okay, friends, there's vertical asymptotes. Next time, horizontal asymptotes.